Hey everyone, welcome back. I've got the F1 hybrid seamless gearbox basically mechanically complete. That's kind of a mouthful, but I've printed out all the mechanical parts at this point, and I've actually gone through a number of shift drums. That was the biggest issue I had with this particular gearbox, and actually the last hybrid gearbox. I have basically a box full of shift drums at this point, but I've gotten all the shift patterns right. I had some errors where I tried to make this all cool and parametric, and what I ended up doing was just causing myself a real headache on the shift drums, and ended up having to go back and really redesign them from scratch. But they're working great. They're actually shifting in the right order now. So like I've talked about in earlier videos, you have one shift drum for the odd gears and one for the even gears, which allows the gearbox controller to essentially control the engagement of the gears and actually be able to overlap, say going from first to second, so that you can perfectly time the dog clutches on the gears so that there's no drop in torque. Both shift drums rotate inwards to increase or go up in a gear number. So for example, they're both at their initial position, so both at neutral right now. And what would happen is you have to have these spinning, of course, so the dog clutches can engage. But there's first gear, and then the next one will be third gear on this shift drum, and then the next one's going to be fifth, and then finally seventh, and it'll actually go to neutral because this is your even shift drum over here, which will have eighth gear. So I wanted to cover one of the biggest challenges that's really made this take so much longer, is the fact that this has to be so accurate. These shafts have to be within about 0.5 millimeters, and in fact the shift drums themselves as well have to be within 0.5 millimeters, and then everything has to be aligned within about 0.5 millimeters. And that's really difficult on something like this with 3D prints. And the reason for that is, your typical 3D print's going to be accurate, if you've got a good printer, to be within, say, 0.2 millimeters. But when you stack, I don't know, like 20 plus items in a row, like so gear, spacer, gear, spacer, gear, spacer, like this, 20 items times, 0.2 millimeters plus or minus, you can be off a few millimeters pretty easily at the end of the shaft. So I spent a huge amount of time trying to work through all this, and ultimately what I decided to do was I have oversized all of the parts by about 0.2 millimeters in length, and I just go through and hand sand them, go in with a dial gauge, measure each part, make sure it matches what's in CAD, and then when I get to the end, hopefully it all lines up and is the exact same length. And that's extremely important, just because there's so many different places in this gearbox, just due to its design, that it's dependent upon accuracy. I mean, these gears are about a millimeter apart, so that, as you can see, like these two gears can quite easily overlap and catch. It's a little easier in the real gearbox. Of course, they have the beauty of being able to machine them out of metal with very accurate machinery, but also each one of these gears is actually tapered, but a shallow draft angle like that is extremely hard to 3D print with FDM. The other reason it needs to be very accurate over its length is because these shift drums are fixed, and they're actually relatively accurate because they're all made in one part, but as you can see, because you've got your center point here, and then you only move 4.5 millimeters, or I think 5 millimeters maybe total, for a shift is all the shift fork moves. If the gear is offset in either direction from the shift drum by more than a millimeter, it won't properly engage the dog clutches and lock the slider into gear. And that's an actual real big problem, and something that took a long time on my previous F1 gearbox to be able to determine what will work in a 3D model versus what they could probably get away with in the real gearbox, where they're going to be much more accurate. oddly enough, by far the most asked question I get is, how does reverse work on an F1 gearbox? And why is it so hard to engage? And just to kind of demonstrate, first of all, we're fully in neutral here. So we're completely, as you can see, I can rotate the shaft here, but the gears, the rollerized gears, aren't rotating. So the motor, if the engine's coming in over here, the engine's going to be rotating this lay shaft like this. So what has to happen is you have to have the entire gearbox in neutral, so none of these gears can be engaged, and I'll show you why in just a second. You also have to have the clutch put in, because you cannot have this shaft spinning either. And so what happens is, to put it into reverse, there's just a hydraulic plunger here, and this is an idler gear. So it's just a gear with a bearing on it. And I have too stiff of a spring in here right now, so it's a little bit flexy. But what's going to happen is, and you can see it's just difficult even for me to get it in there. But once that gear is actually pushed all the way in, it engages with these other two gears for reverse, and they are not rollerized. They're splined to the shaft itself. And when this hydraulic plunger pushes it all the way out, you can see it actually reverses the entire movement of the gearbox. So this is very much like a Bendix drive you would find on a starter motor in a car. The gear teeth are just angled, and the hydraulic piston just fires it into these reverse teeth right here. Again, it's not there for actually using reverse. It's very rarely used in F1. It's really just there from a regulatory standpoint. Okay, so I just wanted to show some of the things that I've finished since the last video mechanically as well. And the first one is, this is the oil pump for the gearbox, and it actually would mount down here. Unfortunately, I have a design error in the input plate, so I need to reprint this. But this would pump oil throughout the gearbox and down the actual shafts themselves. So this is an actual oil galley itself that would feed the input and the lay shafts. The other big thing that I've finished is actually getting all the spline drives for the shift barrels themselves. In a real gearbox, it's going to be all hydraulics. It's going to be a servo valve, really tiny servo valves controlling some sort of rotary hydraulic motor that's going to spin these shift barrels very quickly and very accurately. Since this is a model, I'll be using stepper motors that just use the same kind of pentadrive. I also have an encoder on it, because that's very important, because the dog clutches can essentially be aligned depending on the point that the gear is actually at. And if that's the case, you could skip a step. So you have to know that you've skipped a step to keep moving forward. Otherwise, these stepper motors are kind of just dumb. And I'll go into that a lot more detail when I go into the electronics. And then the last big bit is, I have to actually have the gearbox spinning so that it can shift, because the dog clutches. So on my previous gearbox, there was a huge cover and housing right up here. The beauty of that was I hid all the electronics and the motors and everything else for the gearbox inside this housing. But for this particular gearbox, they don't mount the clutch directly to the gearbox. So what they do instead is, there'll be the clutch, and the clutch pack and everything will be mounted to the engine itself, and there will just be a shaft that goes between the splines on the clutch and the splines on the lay shaft itself to drive the gearbox. So being that there's nowhere to hide the motor, what I've decided to do is actually build a stand to put the gearbox on and hide all the electronics in, which is going to make my life tremendously easier. So the plan is to actually put the motor that will drive this. I just have a little geared motor that will be inside this stand, and I will have a little 3D printed gear that will come up through the stand, and I'll print it in black so it's not easy to see, and that will spin the lay shaft, and thus it will spin the entire gearbox. Okay, so the last thing I want to address, and this is kind of funny to me, I've gotten a lot of comments. I've gotten posts on Reddit. I've gotten a 10-page long email telling me that these are not Formula One gearboxes, and that Formula One gearboxes don't have shift drums, or Formula One gearboxes don't have or only have one shift drum, just a variety of different things. First of all, I wanted to show off kind of that I have two Formula One gearboxes. I can't give you the details, like I said, on this one because it's kind of an insider information as to how I have the plans for this particular one. But this one, I have very good lineage on, and this is going to be an X-Track P1044. You can go look it up. It is an actual Formula One gearbox. I think when I was making the videos back in the couple of years ago, that I had the years a little bit wrong. I believe this is going to be used from something like 2007 to around 2009, maybe 2010. This particular one is loosely based off a combination of the Red Bull and a Marusa gearbox. This is indeed an actual Formula One gearbox. I know a lot of people have sent me pictures or told me that these aren't seamless gearboxes. They are a seamless gearbox because you have to kind of understand what is the definition of seamless. There is no gearbox that will have no drop in torque unless you have something like a dual clutch type of a scenario where you're actually slipping between the two. I've been told, the MotoGPs are the only seamless gearboxes. And, like I've mentioned in some of my earlier videos, Honda at different times, tested different Formula One style gearboxes that are designed like the MotoGP gearboxes. But the reality is there's always a little gap in the mechanics. And these particular gearboxes, particularly this later gearbox, actually can fire the sliders in between the gaps of the clutch teeth. So there's literally the drop in torque is less than a few milliseconds between shifts, and that's essentially seamless. Hope to have most of the electronics at least mounted and set it up for the next video. Hopefully I can actually do some at least initial shift testing. The goal is to try to get this gearbox to like full seamless shifting, but that'll definitely take some additional effort, and I'll go through some of that. It's definitely more technically advanced when I get to that state. Thanks for watching, and stay safe out there. Beep, 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 beep.